Hello and welcome to this webinar on Cloud-First Data Analytics. So, my name is Joris van den Borre, and I will be your host today for the coming 45 minutes. Before we get started, I would like to mention that we have a chat window on the right-hand side of the screen if you are taking this webinar live. Let's see where this is. So, anytime during this session, if you have a question, feel free to post it in the chat box, and one of our colleagues will pick it up over there. And by the end of the session, we will have a short Q&A where our colleagues will have assembled the most common questions, and I will try to answer them live. If we would risk running out of time, please feel free to send an email to myself or to our team. That's Joris at Tropos.io, and I will send up the details afterwards in a follow-up mail. And we will catch up anyhow after the session. If you are watching this online as a post recording, just reach out through our website and we will be sure to get in touch. So the agenda for today is pretty packed, actually. Let's start with the challenges that we typically face as a data analytics team in 2020. We are being disrupted by many new initiatives, new vendors, new cloud strategies. And we want to make sure that whatever comes afterwards in this webinar is going to be relevant for you. So let's try to set the scene first and take it on from there. So as a second item, we want to discuss about what a cloud actually is and how we can procure this. This is quite important, and because we see the shift for a data analytics team move from being purely business focused and data focused to actually being far broader. This is quite an impact. The responsibility of a BI team is getting far broader. There are not lots of new use cases coming in, and we want to make sure that we can procure all of these components in a decent way that is stable over time. So as a third item, I want to discuss about the data platform strategy and how we can source these components that we have put up in our strategy. There's quite a lot of noise in the market, as we noticed last few years. Sometimes it's hard to just position whatever architecture that's being discussed. So we want to discuss the two major components and the two major architectures that live today, and make a quick comparison between that. We can actually fill a full session with that. So we're just going to touch a few concepts here, and likely there will be a follow-up session on those specific architectures in two separate webinars. Finally, we cannot realize this all by ourselves, and we need our teams. We need the people who know our business, the people who have worked with the data before, and we need to make sure that they can be onboarded in whatever initiative we will be launching in the cloud. So we as well as a team, we had to go through these phases, and there are a few key items that I want to share while we did this as a data analytics team, and what we saw with our customers when they were making the same journey. Also a few pointers on how we were able to help them out while they were doing all of this. So by the end, there will be a Q&A. As I said, I'm expecting quite a few questions, as we had a few very interesting questions up front already. So if we cannot cover everything, we will just reach out afterwards. So before we start, and while people are still joining, maybe just a few words about myself. So my name is Joris van den Borre. I am the founder of Tropos.io. We are a Belgium-based data analytics company, and we are fully focused on cloud. So the interesting part about us is that we have been in the data analytics business for 10, 12, some of us even 15 years. So we were in the pre-cloud world, and we have stepped up to the cloud world about 5 years ago. We deliberately chose to work on cloud only as of the conception of Tropos, because the value advantages that we see in cloud are tremendous compared to what we used to do in the past. And nowadays, we do end-to-end data analytics projects for the public sector and the private sector in Belgium and abroad. End-to-end, meaning that many of our customers are not in cloud yet when we first get to meet them. They know they have some kind of a challenge with one of the data analytics use cases they have. They have heard that cloud could be possibly a solution, and they just want to try a few things in cloud. Afterwards, one of these things is likely to succeed, and cloud projects get more mature, and these projects turn into real projects, larger projects, company-wide projects, and eventually in a round phase. So we're basically able to help our clients out in every step of this end-to-end journey. We have started as an independent company just a few years ago, after a few of us being consultants on international projects. But as cloud is getting traction quite a lot lately, the Kronos Group, which is the largest system integrator in Belgium, has decided to fund us. So we got a capital injection, and as of then, we are really able to grow in headcount and in broadness of the offering that we have, which is a great thing. We're really thankful for them for helping us out on that. So I see that quite a few extra people have joined us. We are using a bit of the time that we have, so why don't we dive into the slide material and get started right away with the content of this webinar. So a very interesting trend that we see is the urge to consolidate data efforts. So where in the past we used to think about business intelligence as a discipline, and dashboarding as a discipline, and self-service as a discipline, and even then data science as a discipline with other people, other terms and practices and standards, and then even self-service usage and data wrangling as a different specialty in the business. Nowadays, we seem to want to consolidate all of the efforts. So to think about the organization's data as a whole, so no longer the data warehouse or the enterprise data warehouse, which is the cleansed version of that and the organized version of that, but the whole of the organization's data. And then think in terms of predictable workload and unpredictable workload. And predictable workload in the sense that we know what kind of data products are used by whom and at which SLA. So it is important to know those, because we can automate a lot in that. We can automate the end-to-end process, and we can make sure that if a user uses a number, that we can certify it somehow. Then on the other hand, the unpredictable workload is something that is very hard for IT to manage traditionally. That is because we can't really predict what a business user is demanding at a certain point in time. And typically, we deal with self-service users, so people who are in business, who understands what a database is, who understands the structure of different source systems, and basically want to need all of the data in those systems together. And that is a very unpredictable workload, because we don't really know when it's going to happen, we don't know what the user is going to do, and we don't really know how many users are going to do it at the same time. On the other hand, we have data science, which is more or less the same pattern. So those people, they tend to do very complex, very compute-intensive operations on the data sets that we own, but they don't do them all the time. So it would be a waste to overinvest in capacity to serve those unpredictable use cases, because it's going to be far more expensive than it will probably yield. But on the other hand, not providing capabilities to those types of efforts and those kinds of workloads means that we lose opportunities. Now, what can we do about this? And especially the last part, and the fact that more and more use cases emerge and the need for data and the usage patterns in data is totally different than what they were when we were still just doing data warehouses. So the capacity bottleneck problem is the first thing we will address here. And by introducing a new sourcing model. So where in the past we just bought whatever capacity we needed, we made a capacity plan, and then we did projects on that capacity. That is turned around. And the idea is to now buy capacity when we need it. Capacity being the licenses that we need to serve our audiences, the servers that we need to process and crunch our data, the hard disks and the storage area networks that we need to store all of our data, to even the network capacity to just transport the data to our processing environments and to get the answers back to our end users. So this is a chart that you might have seen before, because more or less all of the cloud vendors use it. And it's a very fundamental idea, but also a very generic idea. It means that the light gray line that is a bit squared is a traditional sourcing model, where you just buy capacity and you plan for usage over a brief period of time, and then when your actual demand, which is your line in black, your actual demands comes at about 80% of your available capacity, then you invest in more capacity. So if you do that, you are very good at tackling those kinds of workloads in a predictable workload column that we had before, but it's very hard to deal with the unpredictable workload columns. So the squared or the stepped chart, it doesn't really apply any longer. It would be far more interesting if we could just buy the capacity that we need from some kind of a capacity pool somewhere in the world, use it while we need it, and then give it back to the capacity pool whenever we are done doing the work we need to do. And that is especially interesting when it comes down to the two typical kinds of capacity we need in data analytics, which is the storage capacity and the compute capacity. Concretely, say that we have data that grows at a steady pace, and we don't want to analyze the data because we don't really have use cases for it, but we know that somewhere in the future, those use cases will definitely emerge. Maybe when we have extra data sets to merge with that, or maybe when we have hired a certain profile that is very proficient at running certain types of analysis. And it would be very advantageous for us to just be able to store that capacity as soon as it's being generated. We don't do any calculations on it, so we don't need to buy or source any computing capacity. We just need to buy storage capacity. And it would be advantageous for us if we just purchase that over time. So every time we use a new gigabyte of data, we pay for one more gigabyte of data. In contrast to the traditional sourcing model, where we would buy terabytes of data in bulk. And the same goes for computing capacity. And this is actually a very interesting remark to make when it comes down to serving both the predictable and the unpredictable workload. Computing capacity means the capability to process data, either to transform it to some kind of a standardized model or to some kind of a report. When we need to transform data, we need a lot of computing capacity, but only during the process of transformation. Same goes for querying the data. And when we want to run a report, or when we want to build an ad hoc combination of data sets, we just need the compute capacity during the period of that operation by our user. For the rest of the day, or maybe the rest of the week, or even the rest of the month, if we don't do anything, we don't need the computing capacity. But when we need it, we need we basically need all of it. All of it to solve our query or our transformation or our analytical demands as soon as possible. And if we are able to source all of it, then it means that our end user satisfaction with the products that we release will increase, because they no longer have to wait for the results of their questions. They just get their answers on the spot. And this is basically, combined with the previous slide, a very interesting insight for us to have. And the fact that we somehow, somewhere, can source storage capacity and compute capacity separately, and that we can buy for that we can pay for it when we use it. Now, how should we source that capacity? Should we source hard disks? Should we source a vendor that says, hey, give me your data and I will store it and I will return it to you when you need it? Should we source the capability to just send a query to some party and then get the answer to that party from that party without knowing how he processes the data, as long as we can guarantee an SLA with them. Those are important questions to ask, especially when it comes down to cloud. And there are a few different sourcing models available today in the cloud. And they are on this slide. So on the left-hand side, we have the total on-premise way of thinking about sourcing capacity. And that means we do everything ourselves. Be it the networking, be it the storage, be it purchasing servers, installing operating systems on servers, installing software on those servers, maintaining the applications. All of that has to be done by, most often, in-house engineers who maintain all of that specifically for our organization, which is a costly business and which is a business that has to be managed as well. And it does not directly contribute to delivering business insights to business people. It merely, within parentheses, empowers them to do their job. But it's still an overhead. When we would go to cloud, there are opportunities to automate. Instead of sourcing all of those servers and installing those operating systems and virtualization systems, why don't we leave that to the cloud vendor and to some other party who is able to buy all of that in bulk, even on a global scale, with thousands or tens of thousands of clients who all have the same questions and the same capacity needs. And they just need compute and storage capabilities at some point in time, but it's not going to be permanent. And when you look at it from their point of view, from a consolidated level, from a capacity pool of level, it means that they can predict what they will need. And so they can buy whatever they need up front and make sure that we always have the capacity at hand when we need it. And if you use this model, which is the infrastructure as a service model, it will mean that we still have to manage a few things ourselves. And so we can source virtual servers, but we would still have to install those operating systems on top of that, which means we are still responsible for managing the security within those servers at that point in time. But then again, we have a server that we fully control, that we can build the way we want, that we can operate the way we want, and that we can deploy for the use case we want. Sometimes, we will discuss a few strategies afterwards, that can be a very interesting move to make, to be very quick and to go to the cloud quick without having to do large adaptations of our current situation. A second model is the platform as a service model. And this is a model where we automate even more and where we want to make sure that we can take advantage of the fact that many customers have the same kinds of challenges globally, want to automate a lot, want to outsource a lot, and do projects where only some tweaking or some configuration of pre-built components is relevant. Which means there's far less time required from a development team in terms of setting up and organizing software to run a project than before. It merely means that our engineers can focus on solving business problems by combining and configuring pre-built application blocks. And so blocks of logic, which we will discuss in the next slide, that will help them and will allow them to build very, very customized, flexible projects without having to manage all of the underlying complexity. And finally, there's a software as a service model, which means that we just close a contract with a vendor and tell them, hey, you have developed a certain capability. I want to use that capability. I want you to manage all of the underlying complexity. I don't want to know what software you use to provision your servers. I don't need to know when you patch. I just want you to process my data. I want you to process my data in a safe and secure way, and I have a contract with you on that. But I'm only going to pay you for the time that you need to process my data. And I don't want to know anything about the complexity that you have to manage underlying. That's just being part of the cost that they will charge you. Now, when we talk about these building blocks, we are entering the domain of platform cloud providers, just like Amazon Web Services. And full disclosure, we are an Amazon Web Services partner, so we know quite a bit of the components that are available within AWS. And just for your information here, this is a listing of a number of components that we could source from AWS. And those components, though, they cover a lot of functions that you will need when you build very specific applications, even beyond data analytics. There are a few capabilities that always come back. So capabilities that have to do with networking and content delivering. So you will always need communication with your own data center and with your own legacy applications. You will need to make sure that it is secure. You will need to make sure that there is failover and that everything works globally and that you have DNS addresses and monitored gateways. Whatever you do, that's a capability that you will need. And when you want to store data, there's always this capability that you will need to just store your data. You will not want to procure hard drives yourself, make sure they land somewhere in a data center of Amazon Web Services. You just want to make sure that you can use the S3 component within the storage block to make sure that you can store your data somewhere. Same goes for data replication. If you have your data on-prem and you want to take advantage of the scalability, so the fact that compute and storage capacity can be sourced separately. If you want to take advantage of that, you will need to replicate your data. And there is a component on this list as well that can do that for you. But then on the other hand, if at some point you want to deal with blockchain, something that we typically don't do within data analytics projects, there's going to be a component for that as well. And same goes for computer vision. If you want to detect what celebrity is present in a certain picture, that is not something that you will do using a database. But there's another component for that. And a developer nowadays who is familiar with cloud knows those components and knows how they work. Ideally knows the in and outs of the very fundamental components, and knows the components that they need to tie together to build a certain kind of data analytics project. And having this kind of sourcing capabilities, and this is really the platform as a service capability that we saw in the previous slide, is a very powerful thing, because it means that you can build teams, project teams, that focus on configuring components from scratch to solve business problems that haven't been able to be solved in the past. By sourcing whatever you need, when you need it, and releasing it when the need is over. That makes it a very cost-efficient way of running projects, as long as your developers know what to do, what components to configure, and how to tie all of these things together. And this is actually just one slice of what a cloud vendor like Amazon Web Services can offer. When we zoom out and look at the broader cloud landscape and focus on the landscape that deals with data analytics, we end up with an even broader slice of the market. And this, for example, this is a list created by a venture capitalist called Matt Turk. And he's a guy who does a yearly roundup of all of the software as a service companies that are relevant when you are dealing with data analytics projects in the cloud. And even here, there are far more names than one could ever recall. And a decent cloud analytics team and a decent cloud analytics strategy will mean that they are able to pick the right components from this slide, complement them with the right components from the previous slide, and make sure that we can cover the predictable workload and the unpredictable workload at the same time to the benefit of our business customers. Now, another interesting part when you deal with cloud means now, up to this point, we have discussed that cloud is basically sourcing capacity from a larger pool. and buying capacity in a certain service model, wisely deciding whether you want to maintain technology yourself or just want to configure it. Now, we haven't discussed the safety and the reliability of those choices yet. What happens if something goes wrong? And what are my responsibilities as a customer? And what are my responsibilities as a buyer from a public cloud platform? And all of these public cloud platforms have more or less the same model in place to explain those concepts. And often they are called the shared responsibility model, which is basically indicating what a cloud supplier can do for you based on an SLA and what you are responsible for as a customer yourself. And for the sake of illustration, I've taken the shared responsibility model from Amazon Web Services in here, where you can see Amazon Web Services on the bottom part of this picture. So what this basically does is saying, hey, AWS is responsible for the hardware, for provisioning the hardware, for making sure that the hardware is globally available, that there are certain data centers being built, that they are organized in a compliant way, that all of that has been documented so we can pass security audits, and that that AWS installs software based on certain contract terms, that the software is maintained, that it's been patched. Amazon is responsible for making sure that everything is secure in terms of cybersecurity, for installing certain database services if we want them, to make sure that we have routers in place, to make sure that we can define virtual network connections. But configuring all of those components is the responsibility of the customer. Of course, AWS can only provide the core capabilities, the technical infrastructure, and the logical building blocks on top of that. As a customer, we are ourselves responsible for making sure that we design governance principles and that we apply them ourselves. And that's what a cloud strategy actually encompasses, making sure that we have a decent way and a consistent way to make use of all of those components that we can source from the cloud vendor. What does it mean? Briefly, basically, you have to be responsible for the way you encrypt your data, the way you access your data, the way you grant access to your cloud platform, and the way your components are configured. So Amazon can provide you with a set of network devices, but if you don't configure them and you leave them open for the whole world to access your very private data sets, you will be responsible yourself as a customer. And this is where the value of having a team that has done a few data analytics projects in the cloud before can add value to. And that is basically understanding how cloud works, how all of these components tie together, what a typical strategy looks like, and so that they can spot black holes in the current strategy, and they can advise on filling those in, or even define the strategy themselves, specifically tied to the data analytics platform. Now, up till now, we have had a discussion on what cloud can bring if you want to do data analytics. But one big question remains, and that is how to get there actually. So say you are in a full on-premise situation, you have your data centers in a local data center, everything is being maintained by your own staff or insourced staff, but all still based on the traditional sourcing models, the CAPEX sourcing models, and the traditional licensing models. How can you go to a cloud environment that basically delivers whatever we have been discussing in the past? Now, there are two pieces of literature that are quite strategic of nature, but also very interesting because they really shed a light on how larger enterprises, and larger as in Fortune 500 enterprises, made that move to the cloud. So two books I really can suggest are Ahead in the Cloud by Andy Jassy and Stephen Orban. Stephen Orban was the head of enterprise architecture, I think, at AWS at the time when he wrote the book. And Andy Jassy is the CEO of Amazon Web Services. So pretty high profiling people there who basically wrote the roadmap from a CIO's point of view on how to go to the cloud. And a bit more tactical, but still very interesting if you're just starting out, is the Cloud Adoption Playbook on Wiley. And what they basically explain is a set of different strategies that you can follow if you want to go to the cloud, starting from your on-premise situation. And those strategies, they follow two axes. One, the x-axis, the horizontal line, is the time to migrate. So how much effort do we need to put in moving the situation we have to a target situation that is in the cloud, and without really defining what that target situation is, of course. The other axis is the y-axis, so the vertical axis. And that is the cost, the effort, and the skills that it takes to execute a certain strategy. And we have, for example, a rehosting strategy that doesn't take a lot of time, doesn't cost a lot of money, adds quite a bit of value when you execute that strategy by going to the cloud, but it's just an entrance level action. If we step up, we have the replatforming, refactoring, and full rebuild options. Now, what those things mean, and specifically for data analytics, are things we are going to discuss in the next slides. And let's basically start with the rehosting strategy and the lift and shift strategy, because it is often the first experience when people go to the cloud. And why is that? It is basically taking all of the installations, software installations that you have on your on-premise situation, and just replicate them to the cloud. And what you are actually doing then is either virtualize the bare metal, the physical servers that are in your data center, or outsource the maintenance of your virtual platform to your cloud provider. It means that you just keep all of the software that you have, all of the configurations that you have. Ideally, you check that your licenses are compatible as well. And you have basically built a virtual data center based on the things that you know. And it's important because it all looks and feels very similar to what people are used of doing. But it gives you a first glimpse of what the cloud could be. It gives you a first feel of what, for example, Amazon Web Services looks like, what those components mean, and how cloud cost is built up, because you're really shifting from a CapEx to an OpEx model then. And it also gives you a feeling of confidence. And it is not to be underestimated. People who know what success looks like in an on-prem situation can then experience what it would mean to go to the cloud and experience the same kind of success. When we look at the gains that this brings for a BI team, I think it's fair to say that the gains are fairly limited. What you would do is move your ETL server, move your BI server, move your self-service analytics tools from an on-prem virtual system to an in-cloud virtual system. And that's great because you can outsource a lot of the maintenance of those machines. It's also great because the procurement times to get a new machine are often slashed. Sometimes it typically takes 6 to 8 weeks to get a server on site. In the cloud, you can get the same server literally in a few minutes. It just takes a few minutes to go from nowhere to a fully furnished virtual server. And if you are in a project phase where you are experimenting or you need to scale up fast, this can be of a material gain. But if you're in a stable situation, you know what your BI system would look like, or your data analytics platform would look like on-prem, and you don't have extra use cases, well, the rehosting strategy is a safe strategy to take as a first step. But typically, we don't think about cloud when everything is going well and everything is running smooth. And typically, we think about cloud when we really face bottlenecks in our data pipelines or our data processing systems. And typically, that is because of one bottleneck. Often it is the database, but sometimes it can also be the BI platform. And a little lift and shift and tinker strategy and the replatform strategy means that you are actually going to execute the first strategy, and the lift and shift strategy, but you are going to replace one key part. And we are going to replace one key element in our data processing pipeline that is really causing a lot of the troubles. And often that is the database. And because the databases on-prem, they are typically limited by even physical boundaries. And you can't put more data in the machine than the machine can handle, or the machine can't process more instructions than its processor is physically able to do so in a certain amount of time. And by replacing a database with a database that is really designed for the clouds, we are able to to improve a lot of the quality of the output of our data analytics platform to our end users by a lot. Because when we look at the experience for an end user, when it is strictly related to business intelligence, the answers to queries come very fast. We are still in on-prem situations where end users have to wait for 10 or 15 minutes or even sometimes hours before they get to answers to reports. In cloud, we can reduce that to minutes or seconds sometimes. So the most impressive example that I have myself from doing real-life projects is a data pipeline that took 11 hours to process overnight, and that sometimes failed. And if that data process failed, then it meant that the business users who arrived at 8 a.m. in the morning the day after, they sometimes didn't have data to start working on. And as this was a daily process, a daily reporting process, and a daily follow-up process, it meant that correcting a data issue, rerunning the data pipeline, didn't even finish within the same working day. And that often meant a day of work lost for our business end users. So that 11 hours processing time was reduced to literally 20 seconds. So from 11 hours to literally 20 seconds by executing the lift, shift, and tinker strategy. And what we did over there was just replacing the legacy, say, database technology by a database technology called Snowflake, built on AWS. What you get out of there as a business team is, I think, clear. Your experience as an analyst or as an executive in consulting data is improved, and because you just get access to your data faster. You can also start expanding your possible population and the people who are going to work with your data platform by a virtual unlimited amount of extra analysts. And because if you onboard new people in an on-prem situation, it means that the same server, the same technology has to deal with more people at the same time. And there is an end to that. But if you're in the cloud and you just purchase whatever you need when you need it, there is no end of it. There's just a budgetary end to it, which is a totally different story for a totally different webinar. But in theory, the amount of business users is unlimited that you can onboard. Now, there is one big challenge with the lift, shift, and tinker strategy. And that is that mixing those legacy components that have been migrated to the cloud in the lift and shift strategy and mixing those components with current technologies that came from the replatforming strategy, from experience, often causes integration challenges. So if we move, for example, ETL logic and put it on top of a cloud data processing platform like a Redshift or a Snowflake, it often means that those processes have been designed by developers to deal with bottlenecks in on-prem situations. And those are often workarounds, smart things that those people did to bypass challenges of the day. Now, if we try to unleash that to a cloud platform, well, it sometimes means that we just don't take advantage of all of the benefits of the cloud platform that we are working with. So, for example, if you would use Snowflake, which is a fully scalable data warehouse technology, we would load gigabytes or terabytes of data into Snowflake and put a reporting solution on top of that. Our end users would benefit because everything is going way smoother and way faster. But processing our data when it is still being processed in a typical ETL tool from our legacy environment, it basically would cost us advantages when it comes down to processing that data. The ideal situation would be that all of the data processing happens within the cloud based on cloud infrastructure that is sourced on demand. And that is what a typical ETL migration doesn't do. We have strategies to work around that, things we specifically do to make sure that we can also get rid of the old ETL legacy. But that's a different tale. Just remember that those solutions, they exist. Now, as a third strategy, we have the refactoring strategy. And the refactoring strategy means that we are going to restructure the legacy and the current developments to just take better advantage of the way we can source capacity in the clouds. And that actually means that we are again building on top of the second strategy, which was the replatforming strategy. But we are actually going to optimize every single component to make sure we can take advantage of the clouds. And that's within the boundaries, of course, of every component. In the case of a typical BI platform, that would mean that we would make sure that our front-end tool doesn't replicate data to make sure that the performance is better, or try to cache data because of performance reasons. That's a huge win because it means we have far less maintenance to do. Our BI team doesn't have to deal with copies of data, doesn't have to maintain or make sure that those copies exist, or even create temporary artifacts. So those little tweaks that these people do to make sure that user satisfaction on performance is met. Now, for a ETL process, it would mean that we would not use the application server any longer that we use for our ETL tool, but that we would actually take advantage of our cloud processing framework to do the ETL, which then turns into ELT, extract, load, and transform. And that's something that has happened in the past with specialty databases. It's called the push-down optimization, and which means that ETL tools can still be used to design logic, to graphically lay out ideas of developers, but the ETL platform is no longer going to do the actual processing. The ETL platform is just going to instruct the database to do certain data transformations within the database itself. And that's actually a very powerful idea there. If we execute that strategy, it means that we don't have to replicate our data any longer. We can just have one place where we store all of our data, and by transforming the data within that place, we have control of every step in every transformation process. And we also have control over all of the replications, if any. And I deliberately say if any, because more and more we see that we don't actually create replications of data any longer. We can deal with data that has actually on-demand transformations built on top of that. So strictly virtual data analytics platforms. And that's very, very powerful, especially when it comes down to dealing with sensitive data. If you deal with sensitive data, say, for example, GDPR sensitive data or social security sensitive data, it means that you always want to audit all sorts of access to that data. So the more replicas of the data sets you have, the more complex it becomes to create an auditable view of data access on that data set. So by storing all of that data inside one place and making sure all of the transformations happen in that place, we can really optimize and simplify that sort of functional requirements. And another gain of executing this strategy is actually something hidden, and that's the license optimization. And that is something that we see more and more lately. Because in the past, we noticed that a lot of vendors put a price on the server capacity that they were using in an on-prem situation. So for example, the amount of cores, processor cores that they needed, or the amount of memory, RAM memory that they needed in a server. Now by moving to cloud, we can still retain the logic that has been built inside of those technologies, but we can have the heavy lifting done by our cloud database or cloud data processing framework, which means less licenses to buy, but retain the same skill set that you have built up over the past years. Now, there are a few challenges still, and the success definitely depends on the legacy technology integrations. So some vendors have been early to recognize the success and the importance of public cloud, and they have prepared their software to play well together with the big names in cloud. So the AWSs, the Snowflakes, the Sparks. But it is at will of the vendor. It's not a standard yet. And if they implement it, it doesn't mean that it's really natively implemented. So for every legacy migration exercise that you need to do, you actually still need to do a few proof of concepts to make sure that the vendor really plays well with the cloud platform. And maybe the biggest drawback that we have in the refactoring strategy, but also in the replatform strategy and the rehosting strategy, is that you still work with legacy products. And that's actually a big deal, because the cloud is not just a technology story. It's even in the third or fourth place just a technology story. Cloud in the first place for us is a new way of delivering results. It's a new way of organizing development teams in an agile fashion, using far more automation than what we would do in the past, using automated version control, using automated deployments, moving to production by using automated processes. And the legacy technology sets that we still carry with us when we execute a refactoring strategy, they often do not support that. So if you're aiming for technological improvements and maybe user satisfaction by solving bottlenecks in your serving layer, in the database that is exposed to your end users, do execute a refactoring strategy. But if you are looking to optimize the throughput time of a project and also to optimize the experience an end user has, take into account that your legacy technology stack may be the burden here. And to deal with that, we have a final strategy, which is a rebuild strategy. And it is exactly what the word says. Just take everything you have and rebuild it using cloud native components. And that may sound pretty harsh to do, but in practice, this is the strategy that many organizations take from the start. And not by rebuilding the legacy that they have, just by executing the rebuild strategy on every new project that they start. Which is an important thing to notice, because it means that they have done quite a bit of technology selections. They have at least the basis of a cloud strategy. They know what components to source. They know how they want to source them. They know how to find their way in the ecosystem of data analytics solution providers, be it Amazon Web Services or one of the partners in the partner ecosystem. And they also know how to design a governance strategy around that. Companies that execute this strategy, they are typically able to use agile in the most literal sense of the word, and delivering on a steady pace, automating all of the overhead that is a burden to a developer, automating all of the overhead that does not directly contribute to business value, and automate a lot of the delivery governance. Yeah? For example, doing automated tests to make sure that if you have a strategy in place to hide personal data, that it is automatically tested that none of the end users can actually see that private data. Interesting things that we have noticed while executing this strategy are basically what I already discussed earlier on, which is allowing the development teams to focus on business value. And this one is hard to underestimate, the little to no data replications end to end. Especially with the larger, the more sensitive data sets, making sure that we have no replicas, making sure that everything runs automated on the single copy of the data we have is very valuable. Now, that was quite a bit of information. So very briefly, what cloud is, how you can source it, a number of strategies to migrate to it, and also how it can be used for data analytics and what the actual advantage is, and so the separation of storage and compute. But let's now talk about data, architectures for data platforms for a while. Because as soon as you enter the world of cloud and cloud data analytics, you often face an avalanche of technologies, terms, practices, beliefs, vendors, components, open source, proprietary, whatnot, elements that make it very difficult to basically get even started. And what we saw from doing projects over, say, the last 5 years, is that there are basically two blueprint architectures in place that can be used if you want to go to cloud. And let's have a look at each one of them in detail. And the first one is what I call here the Data Lake 2.0, which is basically the ecosystem-based approach that you might recognize from the Hadoop era. So Hadoop was the first approach of handling really big data by using commodity hardware and building technology on top of that could manage this commodity hardware by building clusters. And Hadoop was basically an assembly of different smaller technologies. And every technology was developed independently. All of the technologies, they played together pretty well. And they all fulfilled one subtask in running and maintaining a data analytics platform. So Cloudera back then was a big name, Mapper was a big name, and Hortonworks as well were big names. So that market has diminished, has shrunk a bit, and Cloudera has consolidated the remnants of that market. And we noticed that there are still quite a few very large Cloudera deployments out there in the wild on on-prem systems. And those cloud vendors, they saw that as an opportunity. So they saw that if they want to move clients to the cloud, they needed to make sure that all of the investments that were made in on-prem Hadoop deployments, they could be leveraged as easy as possible on their cloud platforms. So what they did was basically offering all of the components that were part of Cloudera and the other Hadoop distributions, as well as components in a managed sense in the cloud platform. So meaning that if you need to replicate your data from an on-prem system to your cloud platform, in the past, for example, you had Apache Flume, which was able to ingest data in your Hadoop platform. Now they have something similar, depending on the cloud vendor, that basically does the same thing. And where in the past you had Spark on site, nowadays you have AWS Glue, which is basically Spark hosted as a service, or Databricks, which is basically the same. And to make sure that all of the Java developments that you did for your Spark projects just could be transported to your cloud environment. Same goes for data science, for self-service, your business intelligence, and your analytics exposure layer. Now, important here to notice is that you also leverage or also replicate all of the concepts of a Hadoop system. And Hadoop did not know what a database is. Hadoop was not built to be a database. Hadoop was built to be a data storage and data processing environment. So instead of working with what we know as tables and what we know as databases, we work with files. So if we execute the Data Lake 2.0 strategy on the cloud, we work with files. We copy files over, we transform files, we cleanse files, we integrate files, and we have to manage files. And there's a big difference between managing files and managing a database. And basically, a file is accessible to anyone, and you really can't do a lot with governance when you deal with files. You have to put something on top of that. And if you want to govern access to files, it will mean that you have to create replications of files. And data replications these days, they seem to be the enemy of every serious governance person. And the more replications you have, the harder it becomes to really govern a situation. So the vendors recognize this, and they notice that apart from a data processing framework, which is typically Spark-based, they need to put a database whatsoever at the end of a data processing pipeline. And just to make sure that the things that an end user wants are present and are available in projects. So that means for the data lake, your data processing step falls back to writing Java code or Python code, and things that a typical data engineer in the strict sense of the word does. Maintaining all of the logic in there in typical software development environments, doing everything in code repositories, making sure you get code automation, code testing, all of there in place. And then hopping over to loading all of that data in a database and making sure that you can apply the traditional business intelligence approaches to that database. So in short, if you want to take this data lake approach, it means that you have to maintain a lot of components. And we see that this architecture is often pitched when organizations are new and moving to the cloud, and because these things are things people recognize from blogs. All of these components, they have fancy names. Kubernetes even comes in. Apache Airflow comes in. Glue comes in. What else do we have? The Hive Metastore comes in. And it sounds fancy because it sounds new and interesting and refreshing. But remember that it's actually designed to be a replacement of 2008, 2010 technology in the cloud in a managed environment. And the big challenge is actually loading all of the data that has been pre-processed in a certain technology with a certain development mindset and a certain way of organizing things, replicating all of that into a data analytics database that comes with their own practices and traditions and ways of organizing things. Means that, well, if you're in a greenfield situation, the Data Lake 2.0 approach is fairly tedious. It takes quite a long time to put every single component in place just to have an infrastructure to start doing your data analytics projects. And the teams that have to do this, they're often large teams that take quite a bit of startup time before they get to any tangible business result. So if you're in a greenfield situation, there is an alternative, of course. And the alternative that we prefer working with these days is based on a smart sourcing strategy. So instead of starting from technology and starting from vendors and starting from blogs and seeing whatever is fancy and new, we decided to start from functions, the things we recognize we need when we want to run certain data analytics projects. And let's start at the left-hand side of the slide. Everything that happens on-prem. And our on-prem situation is limited to just registering data and making sure that data is somewhere readily available to process. And then next to that, we have a part in the cloud that we have to manage ourselves. And so the components that we have to maintain, which are typically our own developments. And then the right-hand side is the data processing infrastructure that we can source as a whole. And at the right-hand side, you can actually see that everything that happened in the middle part and the right part of the previous slide is consolidated as a service. So instead of working with a data processing framework like Spark and then putting a data analytics appliance such as Synapse or Redshift next to that, we decided to consolidate all of that. We didn't really want to work with files any longer because we didn't see a functional need of working with files. We just wanted to store and process data, and that happens in our data processing platform that we source as a service. And the one we like to use there is Snowflake, which is basically a really unique platform that takes data, stores data, processes data using SQL, and gives us the result. And instead of maintaining separate components and making sure all of them play together well and are configured and are auditable, we just decided to outsource that. We don't feel it's our responsibility as a business-focused data analytics team to set up that kind of infrastructure. Nonetheless, we need the capability. And the way we work there is to have our on-prem situation register data, replicate and synchronize all of that data to a self-managed cloud environment, and load it as soon as possible in our Snowflake database. And we still need a few components specific to self-service analytics, to data science, and to business intelligence to make sure that Snowflake is managed. One of the follow-up webinars on this webinar will actually deal with Snowflake and the way it is used in scenarios like self-service and data science these days. This second slide is actually quite a feasible strategy. And because it means that we have far less components to manage, we can build a far more compact governance strategy. Everything is way more auditable and everything is way more securable. And because there are far more contracts to rely on, and the Snowflake contract is a very stable contract, the AWS contract is a very, very stable contract, and everything ties together really well. It is easy, it has shown to be quite easy to pass this kind of contracts through compliance departments, even though they might not be familiar with purchasing cloud. And in practice, it means that you have a very concise overview of how you need to organize data access and log access to make sure that whatever you do in your data platform is trusted. Now, one more thing is how to staff these teams. Yeah, so we have seen that there are a few new architectures in place, and things that are recognizable, but maybe also a bit new. And what if you already have a data analytics team? What if you have quite a bit of knowledge built up about the source systems that you have in your organization, or the transformation that you need to do, and you have a certain amount of people who are knowledgeable about that, or you have a certain amount of people who are knowledgeable about that. So typically, we had to deal with system engineers, backend developers, and front-end developers. System engineers made sure we could have the infrastructure we need. Backend developers were typical ETL developers, and front-end developers are typical people who build dashboards and data visualizations and make sure that data was consumable for end users. Now, the job content of these people has been shaken up by a number of recent developments, be it either just technology developments that made sure that certain technologies are more accessible to business analysts, so they no longer needed IT profiles. And other shakeups are basically related to the emergence of public cloud. So by the emergence of practices like DevOps, and where a developer no longer is just responsible for his development, but also responsible for running whatever piece of software that he has developed. And for system engineers, this means that we don't have the typical system engineer in place any longer. And so the person who deals with physical hardware, and they're replaced by a role called site reliability engineer, sometimes also called a DevOps engineer. What these people do is basically do the same thing as a system engineer does, but in the cloud. And where a system engineer in the past would do things manually or do things physically, site reliability engineers typically think about automation a lot and think about observability a lot. And this observability thing means that everything they do should be monitored, should be measured, they should put KPIs on performance, and they should know how to deal with KPIs that don't turn out too well. Those are fairly new roles. Typically, they go very broad. So if you have ever heard about containerization, that's something a site reliability engineer typically does. But we don't need the full broad skill set of what those people do. And so very often, the data engineers that we deal with, they are knowledgeable enough about systems infrastructure, and they know how to talk with SREs, site reliability engineers. And by assembling the right combination of SREs and data engineers, we are able to set up cloud platforms from scratch with very limited teams. Limited in terms of maybe 1 or 2 SREs who start from scratch and who work towards an end-to-end data analytics platform in a span of 6 months, sometimes 6 months. Now, then you would just have your technology platform set up. And where in the past we would have our ETL developers who would focus on picking up data, transforming that data to some kind of a conformed format and storing that data back again. And these people are replaced by data engineers and analytics engineers. Two new terms who are actually pretty similar. So data engineers typically come from a Hadoop background, typically come from a Java development background, and they think like a programmer. So everything is code-driven, everything is very custom, and everything is really automated as well. What we noticed is that the practice of writing Java code is very specific to software engineering and is often a bit further away from delivering actual business value by talking to business people, which is what we are typically doing when we deal with data analytics. So there's a new role who aims to focus more on that, and that is the analytics engineer. And the analytics engineer basically lends a lot of the good ideas from data engineers on how to maintain technology. They write code as well, but instead of writing Java code, those people write SQL code, SQL code. And they have their frameworks and practices and management technologies around the SQL code to make sure that it is maintainable, governable, and runs well over time. And this analytics engineering role is a kind of profile that is able to talk to a business end user, to write SQL code, to take full benefit of a cloud data platform, to make sure that the cloud data platform is scalable, but without all of the overhead of writing and debugging and testing and maintaining and documenting software code, because it's just SQL. Now, the front-end developers, so the people who typically build our dashboards and data visualizations, that's a different story. So there's still quite a lot of technology in the market that really asks for specifically trained profiles. But we noticed that a few new entrants in the front-end market, they really aim at selling to business embedded analysts. So they no longer sell to IT profiles. They build products that are readily usable by business analysts and can execute codes on cloud data platforms. So those technologies are in there, and the impact of that is that our front-end developer is often just moving to the business side. Or a business analyst who used to do their work in Excel or Microsoft Access is now able to do the same kind of work, but on far larger data sets with far more compliance rules applied by using a new kind of technology that leverages cloud. Now, let's talk about reskilling those teams then. If those new roles are in place, how would you reskill the team that you already have? And so it wouldn't make any sense at all to say that we have to replace the people by new or other people. The most successful cloud initiatives we have seen, they really focus on retraining the people that already are in place, in coaching them and making them acquainted with new principles, but definitely leveraging whatever they know and can do for your organization. So let's start with the site reliability engineers and the data engineers. And the most important thing we have noticed coming from our data background is that they need to get acquainted with PaaS, platform as a service level components. And that is actually the preferred sourcing model that we have when we build a cloud data platform. By purchasing the capacity of the functional building blocks that we need and making sure they can get configured and they play well together while they execute a certain step in a data analytics platform. And it means invest a lot in automation. Automation skills are really key. Continuous integration, continuous deployment skills are really key. And those are typical software engineering principles that exist in, for example, website building. but can be applied to data analytics as well if you really know how to deal with them. If we can do that, it means we can introduce a lot of automation in the workflow, and by automating more, we can guarantee more compliance, more auditability, more certainty, and less risk for our cloud platform. And the same goes for data engineers. So where our people in the past were focusing on their ETL tool, people we deal with nowadays, they still do data transformations, but they write them in SQL, but they use a lot of the automation principles that are also used in setting up and governing the platform as a service components. And when we have a look at the strict data engineering role and the analytics engineering role, it comes down to skilling up in SQL. So people in the past who have been in ETL roles, they are often familiar with SQL. It's a matter of skilling a bit up or learning a new dialect of SQL to make sure that they get fully up and running. And also those DevOps practices. So the fact that a developer also operates whatever piece of code they developed is something that is traditionally not present with our backend engineering profiles that we had. But it's crucial when we do cloud. When we want to be successful in cloud, when we want to reduce those time to market cycles, it is mandatory for those people to learn about the DevOps practices. And our business embedded analysts, they start to pick up SQL as well. And that's a very interesting trend we've seen emerging over the past maybe 2 years. People who said in the past that they would not look beyond their Excel files or their Microsoft Access database, they pick up SQL because they understand that it is a fairly quickly achievable skill, but it can be very powerful when you can just execute SQL code on large data sets. So they're no longer bound by the capabilities of their own laptop. They can just use whatever cloud capacity we have in place. And for those business embedded analysts who do exploration or assembly of temporary data sets, there are a few new point-and-click ELT products in place. So the ELT is specifically chosen here as well. So those products, they use the cloud platforms we put in place to make sure all of the data transformations run decently in our cloud environment. So that was in a really fast tempo, a lot of information regarding moving data analytics to the cloud. It's only scratching the surface. Of course, as you might have noticed, we have discussed about people's roles, about technology, about governance, about legal, about compliance. We have talked about risk, and just try to bring you the core concepts of each of these domains to make sure that you know what you are dealing with when you want to go to cloud. So we are running out of time here by quite a bit, I noticed. And there are also quite a bit questions that came in throughout the course of this webinar. So I propose not to answer these questions now, as everybody already has filled agendas. But let me come back to them offline. I will reach out, or a colleague will reach out after the call and make sure that your questions get answered. So I just want to thank you again for staying with us, staying for the overtime. Thanks for the people who are still here with us. Don't hesitate to reach out to us when you have any questions or want to have a discussion on moving to cloud for data analytics. And I want to invite you for our next webinar that will deal with processing large data sets in cloud using Snowflake. Thanks a lot, and see you next time.